Hi guys, welcome to my YouTube channel, and in today's video we will be discussing about the concept of caching and the caching read strategies, right? So, and before starting this video, I request you guys to please subscribe and like this channel, right? That will motivate me to come up with more technical content. So if you've done so, let's quickly begin with the today's topic. So let's try to understand the concept of caching first, and then we will deep dive into the read strategies, right? And because read strategy revolves around how you read a particular data from your cache memory, right? But before understanding and doing a deep dive into the read strategies, let's first understand what is cache memory. All right, so now before discussing this, right, generally what happens is my video goes till 40 to 45 minutes. So what I have decided is I will not try to cover everything in one single video. Rather, I will try to create small videos of like 15 to 20 minutes, and will try to create multiple videos on a topic, right? So for example, in this video of caching, we will try covering read strategies. Maybe in another we will try covering the eviction strategies, and in the other video we'll try to cover the replacement policies and all, right? So let's quickly begin with the caching, the concept of caching. So let's discuss the caching not in the technical form, in very basic real life example. So everybody, if we have our viewer who is just started his career at age 22, can understand caching, and a person who is the 6 years of his career can also understand the caching, right? So let's say I, as a person, likes coffee a lot, right? So the way I prefer having my coffee is I go out to a shop and ask the shopkeeper to prepare a coffee, right? That's one way to get a cup of coffee for myself. In this whole scenario, what happens is I have to go out to my house, right, and walk to the shop and ask the shopkeeper to prepare a coffee. Until the time I have to wait, right? So let's understand the basic fundamental requirement why we have caching in the first place, right? Now in this scenario, if you see, I as a person have to go out, so that takes some energy and time as well. So if you see, if I have to walk around 2 kilometers from my house to get a cup of coffee, so that walking 2 kilometers will consume some time, right? So let's say it takes my half an hour to get a cup of coffee, or let's say it takes 10 minutes, or let's say it takes 20 minutes to get a cup of coffee. So what I decided, that rather than let's not go to the shop to get the coffee, what I can do is, the most preferable option is I will order a coffee machine, and then I'll keep that in my home, and that will be my personal coffee machine, and I'll try to, whenever I want, I'll prepare one coffee for myself, right? So if you see in this scenario, what happens is, the coffee that I used to get in 20 minutes, right, now I can get that same coffee in just 5 minutes, right? So you see, that's the concept of caching, right? So what happens is, everything is running around increase the way. So when I bought a coffee machine, what happened is the total time taken is decreased, my performance increased, right? So all those things, everything got improved. You see, everything got improved. So that's where the concept of caching comes in. Now think in this scenario that I am a server, right? And then I need a coffee. My coffee is a data item X, and the data item X could be anything, right? If you're talking in terms of backend engineering, or you're talking in terms of distributed system, the data item could be anything, right? Any resource that your server needs. Now your cache memory is your coffee machine in my house, right? So and then my main database, let's say, is the shop where I used to walk around 20 minutes and get that cup of coffee. So what I did is, rather than keep on going to the shop, I am kind of now preparing the coffee in my house as well. So I'm going to my coffee machine, preparing a coffee in just like 5 minutes. So everything got improved, right? So my coffee machine is my cache memory. So everything that I want frequently, what I do is, rather than putting all the effort in terms of my performance, my time, my number of cycles, for the execution. What I'll do is I'll try to minimize this everything, and I'll keep that element that I'm trying to access frequently into somewhere in a temporary storage where I can access it very easily, right, in very minimal time. So that's the concept of caching, right? So if you move on to my next slide, you see I have defined as well that the caching is a temporary storage location of our data, right? And that's what we understand with this real life example. So now I don't have to make you understand in terms of going in very technical depth, right? But I can give you an example. Let's say you have your e-commerce architecture system in place. Now a lot of suppliers or a lot of retailers have products, right? So let's say product, they keep on creating product and keep on reading product, all those operations they keep on doing from database. So product is something that won't change over the period of time. Let's say if you have a Raymond shop, a Raymond shirt, right? That Raymond shirt might not get deleted from the system very frequently. So what you do is every time you want that Raymond shirt, or there is a place, right, where the geographical location where the Raymond shirt is being accessed frequently, right, is being read frequently, what I can do is I can pick that particular Raymond shop a product item and keep that into my cache memory rather than directly calling to my database, right? So the benefit that comes out of doing so, all those things, right, using the cache memory, and the main concept, if you can have cache memory to increase the performance of multiple things. You can have your cache memory at application server. You can use a cache memory for your database, right? You can use your cache memory for your DNS. You can use it for load balancer. Anywhere, right? Anywhere where you want to increase the performance and you see any scope of improvement where your data is kind of static and you think that data won't be changing very frequently, you put a cache and put those elements there, and then use some kind of and tune in your cache memory and then start using it, right? So that will, to be very particular, it will enhance the overall performance of your system, right? So now so this was whole conversation around your cache memory. Now you see, let's go to your diagram and try to understand from a very basic diagram, right? So let's say this is your server, right, and then this is your database, right? And then this server wants to read element X from database again and again. So you see, even this call is also a network call, right? Because every database call, it's a network call. Now you see, if I want to read the element X again and again, let's say 100 times, now this server will end up calling this database, right, 100 times, right, which will degrade the performance of system. Let's take another example. Now let's say you want to implement a duplicate check, right? Now you have X element in your database, although to correctly implement a duplicate check, you have probabilistic data structures like Bloom filter. That's a separate topic related to system design. We won't be talking about it. Let's take very basic example so everybody can understand. You have 1000 entries in your database. Every time some insert operation comes in, you want to test that if that the element that is being inserted in database is present already in the list of the 1000 which is presented in the database or not, right? You want to perform this duplicate check. What you do is, every time an insert operation comes in, you go to your database and perform a duplicate check. You go to database, grab out your 1000 entries, perform a duplicate check. Now what happens is, if your insert operation comes, let's say 5000 times, what you're doing is you are again going to your database and then what you doing is trying to get the 1000 entries again and again 5000 times. So those are unnecessary network calls, right? Those are unnecessary network calls. So the overall enhancement in this system can be done is, if you go down, then the overall enhancement that can be done is, let's say if this is your server and then this is your database, right? So what I'll do is, I will implement a cache memory, right? Let's say now this is my cache memory, right? So what I'll do is I will first go to my first I'll go to database, let's say, and then we'll understand how the read strategy will work. That's very basic, I'm trying to explain you. I'll go to database and then I will try to see if X is present. Then I'll keep those 1000 entries, right? 1000 entries here, right? Now this network call is costly. This is very costly operation, right? When I say costly operation, means it's taking more resources, more time in terms of your system. It's more complex operation, right? What you've done is you have stored those 1000 entries in your cache memory, and this is your cache. So rather than now, next time your insert operation comes, this is IX. Now next time your IJ comes in, it won't go to your database directly. It will say if your J is present or not already, right? So that improves the performance, overall performance of the system. And secondly, if you see, if let's say this API call, let's say this is an API call of insert, right? If that takes let's say 1000 milliseconds, right, to complete the operation. Now since your cache memory is closer to your application server and very close to your application server, so what happens is this might take only 50 milliseconds, right? So you see that also enhance your latency as well, right? And also you see, if you keep on doing these network calls again and again, using these network calls again and again to call your database, you're also increasing bandwidth of the network. So, and if you're not calling your database again, you're only accessing from your cache memory, you're also decreasing the network bandwidth. So you see, if you sit and think around the number of options to why we should use cache memory, I'm sure you will end up having n number of options that why cache memory is better to use every time you want to enhance and optimize your overall system architecture, right? So that's the basic concept, that concept of caching, and why we should use caching and why we have caching in the first place itself, right? Let's move around. I've already taken 13 minutes, right? I speak a lot, but that's okay. The main agenda is to make you guys understand the concept well, understand the fundamentals well, right? So if anyone asks you the concept, even if in case you are sleeping, you should be in the condition to explain that person, right? So now let's understand the terms cache hit, cache miss, and cache eviction, right? So cache hit is the situation where, let's say, if you're looking up for something in your cache and that particular element X is already present in your cache, so that means it's a cache hit, right? And then cache miss is, let's say, if you are looking for an element X, however that particular element X is not present in your cache, so that's a cache miss, right? So how many cache hits you have versus how many cache miss you have, those kind of metrics matters a lot if you are tuning in or trying to optimize your system well, right? So now the third thing is cache eviction. So there are three things, right? So but however we will only discuss only for 30-40 seconds, and then we will go and I'll create a separate video only on cache eviction strategies, where you have write back, write through, write around caches and all those things, right? Cache eviction is, let's say you have some kind of data element, right? Let's go back and understand. So you see, when you are going to perform this operation, right? So this is your cache hash. Now if you in the server, if you're trying to look up for an element, let's say you're trying to read an element Z, but that particular element is not present, it's the cache miss, right? Now let's move on and understand. Now you have this cache memory. Now understand, cache is a temporary storage. That also means it's very small in size. You cannot have a big size cache memory, otherwise you will lose the whole concept of caching, right? So let's say you will always have, let's say you have these slots in your cache. Your caching won't be this much small, it's only for educational purpose. So let's say you have your caching 0, 1, 2, 3 and 4. You have element A, you have element B, you have element E, you have element Z, you have element K, right? Now what happens is you you want to insert an element into this cache memory, right? This is your cache memory. You want to insert, you want to add, or you want to append any element. Let's say add, you want to add L, right, into this cache memory. Now you see, you only have 5 slots, right, in this cache memory. So only till 5 elements you can add in this cache memory. Now the only way possible to add this element in your cache memory, that you will have to remove one element, right? On which basis you will remove that particular element is being something which is defined by your eviction replacement policy. So which element will be replaced? Maybe your K will be replaced, maybe your B can be replaced, but that is something which is defined by your algorithm, which replacement policy you are using, LRU, LFU, etc., etc., so and so forth. Now there is also how your, because add, you see, add is what kind of operation? It's a write operation, right? How that element L will be returned to your cache memory is being something which is being driven by your eviction. So that is cache eviction. So now let's move on and understood the important part on which this whole video I targeted to create this whole video, right? So which is now read strategies, right? Now the read strategy, you have two kind of strategy in caches, right? So you may be wondering, okay, we have Redis cache, but we don't end up, I don't know what is this you're talking about, read through cache, what is read? I don't care about it. Only thing I know that I already have my mem cache, or I'm using Redis in my organization. All I do is keep on performing all those operations. But how your internally caching works, that is something too important to understand, right? Those are the fundamentals we're targeting. So read through cache and read aside cache, those are, so let's discuss about read through cache first. So this is the main overall idea of your read through cache. Alright guys, so in the read through cache strategy, what happens is your, for example, this is your server, right, and this is your database, and then this is your cache memory. Now what happens is your server wants to access and data, let's say access a data item X, right? Any resource, server resource. When I say resource, that means any data, right? It could be username, password, XYZ, any data, right, that you are using as part of your API, business logic, any complex logic, so and so forth. Now let's say your server wants to read that data. It will first look up into your cache memory, right? And then it sees that that particular data element X is not present in your cache memory. Now what happens is this guy will directly go to your database, right, and then it will look up for your particular data element X, right? Now when the data element X will be fetched from your database, it will first be returned to your cache memory, right, and then from your cache memory it will be sent to your server, right? So you see, it's a 5-step process. Server first goes to your cache memory, and then from your cache memory, if that particular element is not present in your cache memory, it goes to your database, and then you're from database, if from database that particular data item, right, gets returned to your cache memory, and then it goes to your server, right? So that's the very read through cache strategy, right? Very simple. You first look up at your cache memory. If you see a cache miss, that means you don't have the data present. It goes to the database, get it for you, and then it will save it accordingly and then send it to the server. That's how your read cache strategy works. And then you have your database and your cache and your server, right, and all those things same, right? And but in your cache aside cache strategy, this is not the case. It works the way it will work is your cache first goes to your cache. It says that it's a miss, it's not present, right? So what it does is it will, your server, itself will directly go to your database, right? And then from database it will try to bring up the element, and then it will use that element. Now your server has the element X because it was not present in the cache memory, it was a miss. It went directly to the database and it take it out, right? And then once it has now the data element X, now it will send the X element to update the cache again to your cache memory. So now by the end you will have your cache memory updated, right? And then in this case, as part of the write operation itself, you have your cache memory updated, right? Here if you see, your server is directly being involved in updating your cache memory, but here if you see, your server is not directly being involved in updating your cache memory, right? So each type of strategy has its own advantages and disadvantages. That purely depends on your requirement, the particular requirement you have, right? And accordingly you can select one kind of the strategy. That was the about, and it's very straightforward. Just nothing much kind of rocket science into it. First, your server goes through the cache, right? And then it doesn't go through the cache, rather it gets the data element again and then it updates it into the cache memory, right? So for example, you can look is something at the server level itself. You are maintaining a mem cache, and then you first look everything you want to, for example a username, you first, or for let's say a product, you first look that particular product in your mem cache first at your which is at your application server level, and then if it's not present, what you do is you make a database call, and then once you have the data from your database, then you update your mem cache. Next time when it comes, you will again go back to your mem cache and see that particular data is present in your mem cache or not. Then this time you will find, oh okay, so that particular item is present, so it will directly fetch that element from there. It won't be cache miss this time, it will be cache hit, right? So that's how your read aside cache strategy will work, right? So I believe that we have covered the basic concept of caching using a real life example. We also understood that how your cache memory works and what are the actual benefits out of it, and we also discussed some kind of basic terminology upon cache hit, cache miss and cache eviction, where we see cache hit if you are looking out for something that is present in your cache memory. If you are looking out for something that is not present in your cache memory, it will be a cache miss. And if you want to add on insert some more elements into your cache memory, so that will be driven by your eviction policies, so which element to evict out, right, in order to insert more. So this is the cache eviction. And then we also understood the read strategies, and then we understood your cache through strategy, where everything will go through your cache, even the data item that comes out of database will go through the cache, right? And then the read side cache strategy, it doesn't go through the cache, rather server directly go look up into the cache memory. If it's not present, directly go to the database and then take out the value and then update the cache memory later in the end of it, right? So that's how your cache aside strategy works. So that was the brief over your cache read strategies. Maybe probably in the next video I'll come up with the replacement policy, all the eviction policies, and then we can also understand the cache invalidation, write back, write through, all those things, right? So thank you so much guys, and please subscribe and like this video in case you have not, right? Thank you so much.